Hello everyone and welcome to the next section in Newton's laws that we're going to deal with, and we'll be dealing with force diagrams for this video, grade 11. Alright, so force diagrams are sketches of the physical situation you are dealing with arrows for all the forces acting on the system. The length of the arrows indicate the magnitude of the force. So just like in the diagram below, there is a block, and there are two forces acting on it. Alright, the two forces acting on it are the force of gravity, Fg, and the normal force. Alright, so we draw the block. Alright, and this is very, very important to denote. If you have a question and they tell you what you are dealing with, if you're dealing with a block, a stone, a ball, a car, it's important to actually draw out the object as best as you can, and for a block it's simple. We actually draw the block and the surface, and we indicate the two forces acting on the block. Alright, as in the diagram, the force of gravity in pink going down, and the normal force in blue going in the opposite direction. You can see, judging from the length of the arrows, okay, we can see that the normal force and the gravitational force are sort of the same length, alright, or the same size. Alright, so they cancel each other out because they are the same size. Okay, and often the normal force is of the same magnitude of the gravitational force, just in the opposite direction. Okay, now we are going to be looking at another type of diagram used when depicting force, or the forces acting on an object, and this is called the free body diagram. And this is how it looks. So in a free body diagram, the object of interest is drawn as a dot, and all the forces acting on it are drawn as arrows pointing away from the dot. Alright, so taking the same diagram, alright, with only the two forces, gravity and the normal force, acting on the block. Now we just take the block and we draw it as a dot, alright, and then we draw the two arrows pointing outwards, alright, from the dot. So again, the gravitational force in pink, Fg going downwards, and the blue, the normal force, going upwards away from the block. And you do the same if there were more forces acting on the block. Force applied or force of friction would be to the left, and force applied would be to the right. Okay, so these are not very difficult. These are very easy marks in the exam or in the test. Okay, perfect. Now, let's go to the next slide, which I want to talk about components. Alright, so there are three different components of gravitational force. Alright, one is the force of gravity. Other is the force of gravity that is perpendicular to the object. And there's a gravitational force which is parallel to the object. Now, these components of gravity applying to objects that are represented on a incline or on a slope. Okay, so what we're going to do is we're going to just go have a look at how those So I've drawn them for you. I've drawn an object on the slope here for you, a block that is sliding down, alright, on a slope which is at an angle of theta. Right, here is my angle. Over here, my angle theta. Okay, and so I've drawn Fg is going, right, if I have to draw the block, right, and just a piece of the surface. Alright, there we go. I've just drawn a small piece. Gravitational force is still going down. Alright, so gravitational force is still going down. Right, down like this. Okay, it's still going straight down. Does not change. This is still Fg. Okay, then we have Fg perpendicular, which is also depicted as Fgy for the y-axis. Okay, very important to denote. okay, for the y-axis, okay, and that is going down like this, okay. So that is your FG perpendicular. It's perpendicular at a right angle to the slope, okay, or FGY, and then there's FG parallel, all right, parallel, okay, in other words, in the same direction as the slope, okay, and this is FG parallel or FGX, all right. And that is how it would look. And here, angle theta corresponds to this angle here. So this is also angle theta of the same magnitude. Okay, when calculating the different components. Alright, so the formula for calculating the different sizes or magnitudes of the different force components of gravity is, in order to calculate the component, the magnitude of the force that is perpendicular to the slope, it would be taken by Fg cos theta. Alright, so Fg perpendicular or Fgy is calculated by taking the gravitational force times cos of theta, because cos theta is adjacent over hypotenuse. Okay, so when you're calculating the one side, it's Fg times cos theta. Then to work out the x component, or the component which is parallel to the slope, alright, we'll take Fg sine theta, alright, because sine theta is opposite over hypotenuse. So in order to find this side here, we take the hypotenuse times sine theta, and hypotenuse is Fg. So again, Fg perpendicular is Fg is equal to Fg times cos theta, and then Fg parallel is equal to Fg times sine theta. Alright, now in the next video, I will be taking a look at some exercises involving drawing force diagrams, drawing free body diagrams, as well as calculating the different components of gravity.